Okay, shall we start the class now? Okay, listen. So in the previous class, what we have done, we have calculated the bending moment diagram for this problem, right? For this problem, we have calculated the bending moment diagram. Now we will calculate the shear force diagram for this. Now for that, what we need to do for the given problem, like as we know that a cantilever beam subjected to different point loads as well as the UDL. At the free end, we have 20 kilonewton over here. At point we'll make sections over here. A, this section B, this is section C, this is section D. At section D we have 20 kilonewton. At section D C we have 10. At B we have 15. At A we have nothing. Like it is fixed over here. In between B and C we have UDL. For this type of problem, how we need to approach with the what we call shear force. To calculate shear force, the simple one as we have already seen, shear force which is acting at a point D means we need to calculate from here. So shear force which is acting at a D is nothing but, as we know that shear force is nothing but summation of, that is nothing but summation of vertical forces acting on the beam. Summation of vertical forces acting on the beam. Here we have the force which is nothing but plus positive 20 kilonewton which is acting at this point D. Clear? This is nothing but shear force. Whereas bending moment is nothing but force into distance. Shear force is nothing but only the force which is acting. That is nothing but point load. Similarly, at a point C, shear force at a point C, at this point. Now tell me, what is the shear force? The vertical summation of vertical forces which are acting to the right of this means we have positive 20 kilonewton and positive 10 kilonewton. These two forces which are acting to the right of this. So it should be positive 30 kilonewton. At shear force at point B. Now you need to tell what is the shear force at point B. First we add this, like we have 3 point loads. Those are nothing but shear force at point D is nothing but 20 kilonewton plus shear force at point C is nothing but 10 kilonewton and the shear force at point B is nothing but 15 kilonewton. Apart from this, we have UDL. What we need to do with this UDL? First, we need to convert this UDL into point load. If you convert UDL into point load, that is more than enough. That's what we need. So how we need to convert UDL into point load? UDL intensity is 12 kilonewton per meter we have into the distance. Distance is nothing but the UDL. It is spreaded 2 meter. Clear? This is your intensity of load. This is your distance. It is how you need to calculate UDL into point load. UDL into point load. This is how you need to convert. Now tell me the answer for this.
69 kilonewton.
69 ना?
Yes sir.
सभी का आंसर उतना ही आ रहा है ना? 69 kilonewton. This is positive. Similarly, shear force at point A. At point A, if you see the right side, we have all the forces which we have already added. So it should be 69. You can add once more. If you want to calculate shear force at point A, again we need to add this force. 20 plus 10 plus 15, again this. So if you add all these forces, you will get the same answer. Clear? If you have any doubt here, you can ask now. Do you have any doubt here? किसी को भी doubt है क्या इधर? नहीं. Okay. Now once we calculate shear force, next what we need to do? What we need to do here?
Shear force diagram.
Shear force diagram. Okay. Shear force diagram. See. You just note down the values. We'll draw shear force diagram here itself. Okay. See, to draw shear force diagram, what we need to do? First, we need to take a reference line. For example, this is our reference line, which is the parallel to this. Since shear force all are in positive, what we'll do? We'll take here. We'll take a reference line. This is the reference line. Once you take the reference line, next what we need to do? We need to mark the points, the sections. This is nothing but your section A. This is your section A. Here we have parallel to this, parallel to this. Here we have section B, and here parallel to this we have section C over here. Here we have section B. Once we do this, next step, what we need to do here? The intensity of load at D. What is the intensity of load? कितना है भाई इधर डी
20
में?
kilometer.
हाँ
20.
20 like okay. Draw a 2 centimeter line. It is upward because as we know that these are nothing but positive loads. Similarly at C we have 30 3 centimeter. At B
69.
At B we have 69. At A we have again 69. Right? Okay. Once we do this, the next step is, while you are joining these lines, make sure that if there is a UDL, so you keep in your mind, now we are drawing shear force diagram. For shear force diagram, whenever there is a UDL, make sure that whenever there is a UDL in the shear force diagram, it should be inclined one. It should be inclined one. Whereas if you are drawing bending moment diagram, if you are drawing bending moment, if there is a UDL, then it should be a parabolic.
Parabolic.
If you are drawing shear force diagram, when it is subjected to UDL, shear force diagram should come in the inclined line. If it is a BMD, shear force diagram, bending moment diagram should be the parabolic. And the remaining are nothing but your straight lines. Here we have straight line, and here we have straight line from here to here. You mentioned the quantity, the intensity of load. Here we have 69. Here we have 69 kilonewton. Here we have kilonewton. Here we have how much? 30, right? 30 kilonewton. Here we have 20. Now tell me, is it easy or difficult? Is it easy or difficult?
Easy.
After analyzing the shear force and bending moment for cantilever subjected to point load and UDL. So it is very easy. So what I will do now, I will take one question paper. We will solve that question paper, so that you will get the confidence in that. So we can easily calculate. You want one more problem? You want to solve one more problem on this? You note on this problem. You note on this and tell me the answer. A cantilever beam carries UDL and a cantilever beam carries UDL and UDL in the sense uniformly distributed load and point loads. A cantilever beam carries uniformly distributed load and point loads as shown in the figure. Draw shear force and bending moment diagram. You copy this figure. It is 2 kilonewton over here. Here it is 3 kilonewton, and this is nothing but the intensity of load is 10 kilonewton per meter. This is 1 meter. This is 1.5 meter. This is 2 meter. This is 0.5 meter. And you name it as A, B, C, D, and E. It is not necessary you need to name this the same thing. You can name it in a different way. Now you calculate shear force and bending moment for a cantilever being subjected to point load and UDL. Now I want answer from you.
Sir, how
And
much length is that? C and D?
which one? C and D? Yeah?
Yes.
C and D is 2 meter. C and D is 2 meter. B and C is 1.5 meter. And A and B is 1 meter. And D and E is 0.5. 1.5 to 4, 5. Total is 5 meter. Total is 5 meter. Now, see, tell your friends to join the class. Like it will be very good than offline classes. Offline classes से अच्छा explain हो जाता है इधर. You can easily understand better than offline classes because you will get the same questions and same answer. I hope so. You are understanding the concept. Here we can use different pen. You can see the directly your board on screen, and you can record my section also. This session also you can record, and you can watch it again. So you tell your friends to join the class, and I can't help them if they don't join the class. Now, shear force at E, shear force at D, shear force at C, shear force at A. Tell me the answers. Tell me the answers. उमर फारूक सॉल्व कर. तेरा इन्हें कहाँ है वो जीशान है क्या उसका नाम? जवाद और जीशन कहाँ गए सभी? नहीं होना क्या क्लास सबको भी?
सर फर्स्ट ने 0 रे.
shear force पे shear force at E. We need to calculate shear force ಅಪ್ಪ. shear force ಇಲ್ಲಿ ಏನಾಯ್ತು? ಫೋರ್ಸ್ ಇಲ್ಲಿ ಐತಲ್ಲ, 0 ಹೆಂಗಾಗತ್ತ? ನಾವು ಫೋರ್ಸ್ ಇಂಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಂದ್ರೆ ಏನು? ಫೋರ್ಸ್ ಅಂದ್ರೆ ಡಿಸ್ಟೆನ್ಸ್ ಅಂದ್ರೆ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್. ಶಿಯರ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಬರೀ ಫೋರ್ಸ್.
ಹಾ ಸರ್.
ಹಿಂಗಂದ್ರೆ ಹೆಂಗ್
होगा सर फर्स्ट का.
पॉजिटिव नेगेटिव. Positive 2 kilonewton at this point.
2.
Now tell me, what is the shear force at here? What is the shear force at here? What is the shear force at here? What is the shear force at here?
Point load. Point load is 20 kilonewton, sir.
ಎಲ್ಲಪ್ಪ? D
Point
ಒಳಗೆ?
load 20 kilonewton.
D ಒಳಗೆ ಎಷ್ಟು ಐತಳಪ್ಪ?
Point load, sir.
ಇಲ್ಲಿ ಎಷ್ಟು ಐತಳ? What is the shear force at point D?
22.
At point D 22, At point D, at point C, at point B, at point A.
Sir, at point D, 1 kilonewton, sir.
One, eh?
Sir.
How come one?
22, sir.
Sir, 2 into 0.5, sir.
See. Now what
4,
I'll
sir.
do, I
Distance
will
B.
take a section and what are the forces acting right to this? What are the forces acting right to this?
2 kilonewton, sir.
Only 2 kilonewton. At this point,
Shear force,
10.
no, sir?
if you
Yes, sir, shear
consider
force.
this point, if you consider at point C, we have the UDL as well as point load. But at this point, we don't have any UDL. We have only point load. So to write off this, we need to see. At point D, we have only this force. That is nothing but plus 2 kilonewton only. If you consider at this point, we have these two forces. That is nothing but 2 kilonewton plus we have this one 10 kilonewton. 10 kilonewton per meter we have, and the length is 2 meter into 2 meter. Meter get
22.
cancels and you will get the answer. It will be the 22. And at the A, you tell me the answer no. Sorry, at B. Shear force at B and shear force at A. If you are not understanding, let me know, I will explain. Don't hesitate to ask the questions.
25.
कौन सा
Sir,
25
shear
आया
force
था?
at C is 22.
हाँ? Shear force at point B.
25, sir. Shear force of B.
Shear force at point A.
Point B, 25. Point
Shear force at point A.
25, sir.
Okay, fine. Now I'll tell you. We'll draw the shear force diagram now. Shear force diagram डालेंगे सब अब मिलके. To draw shear force diagram, what we need to do first? First, we need to take a reference line, right? For example, this is our reference line because as we know that shear forces are in the positive. Once you take the reference line, what we need to do? We need to draw the magnitude of the load. Next, for example, you mark down this one. This is section A. This is section A. This is section B. This is section C. This is section D. This is section E. Once you do this, next step. Next step. The intensity of load at D at E. कितना है लोड इधर? 2 kilonewton.
2
2
kilonewton.
centimeter.
2 kilonewton.
2 centimeter. Okay. Next at point D, again we have same. That is 2.
2 kilonewton.
Okay. At point C. At point C.
22.
At point C कितना है? 22 है ना? 22.
Yes, sir, 22.
Yes, sir.
Next at point B. At point B again
25.
20.
25. 5.
इसको थोड़ा छोटा करेंगे. हाँ?
Yes.
इसको थोड़ा छोटा है. ये 25 है. Okay. At point A.
25, same.
Now how we need to add the lines now? How we need to join the lines? Whenever there is a UDL, in the shear force
UDL.
diagram, what we need to do? It should be
Inclined.
line. Other than this, all are the parallel lines.
Straight. Parallel lines.
Straight line. Now you need to mention here the values. What is the value here? 2 kilonewton.
2 kilonewton.
Here we have
2 kilonewton.
Here
22 kilonewton.
Here we have 25.
20.
Here we have 25. To
25
mention the unit, don't forget to mention the unit. This is nothing but positive. This is the shear force diagram. Is it easy?
Yes, sir.
Okay. Similarly, you draw for bending moment diagram. Draw bending moment diagram for this.
Bending
Sir,
moment at
First, you
zero.
need to calculate. First we need to calculate bending moment
at E.
at E. Tell me the answer now. Bending moment at
0.
E. 0. Okay. 0. What is the unit?
0, sir.
Unit.
Kilonewton. Kilonewtons.
Kilonewton
0
meter.
kilonewton.
Force into distance
Per
is
meter.
nothing.
Meter.
Yeah, meter. Kilonewton
Next,
meter.
bending moment at D.
-1. Yes, sir.
Minus.
1. Mid kilonewton meter.
Yes, minus. How come 1?
-1.
2
1.
kilonewton into the
Sir.
distance
2
is
kilonewton
0.5.
into 0.5.
0.5 meter. This is nothing. Force into distance is nothing but 1 kilonewton, right? Minus 1 kilonewton
Yes,
meter.
sir. Hmm.
Next, bending moment at a point C. Tell me the answer now.
-23 kilonewton
So first,
at point
this
C.
force into distance, that is nothing but -2
Yeah.
into how much? 2.5.
1 into 2 meter.
2.5. This is the 2.5, right?
Yes, sir. 2.5.
Next,
2.5 into 2
again minus. We have this one. 10 kilonewton per meter
per
into the
meter
distance
into
is
2 meter.
2 meter. This is nothing but your force into distance is now
Force
where it is acting.
1 meter, sir.
It is acting at the 1 meter. Means
Center.
it is acting at the center. Means 1 meter. From here to here it is how
1.
much distance? From here to here it is
So 1.5. 1.5.
1.1 point. Now simplify and tell me the answer.
1.5.
Now simplify this and tell me the answer.
Three. 3 into 2.
-30.
Minus
-35 बरोबर सर.
So,
not opinion, sir.
-35 सर.
Hmm? Just I'll simplify ಮಾಡಿರ್ತಾನ.
sir, at point E, at point D, sir.
Yes. At point E it is 0.
At,
At point D. At point D. How much? 1 kilonewton. 1 kilonewton meter. Now at a
yes,
point
sir.
at a point C.
At point C, sir.
Hmm. Yeah, you want me to write clearly here? और एक बार लिख कर बताना क्या तुम्हारे को नहीं मालूम हो रहा बोले
Yes, sir.
तो ये सब निकाल देंगे बहुत है उसका. Now, as we have calculated at point E and point D, clear? We need to calculate what is the bending moment at the point. To calculate bending moment at the point C, what we need to see? We need to see what are the forces which are acting right to this. We know that we have two forces, 2 kilonewton and 10 kilonewton per meter. Here we have UDL and point load. First we will consider point load. Point load, that is nothing but minus 2 kilonewton. As we know that bending moment is nothing but minus force into distance.
Force into displacement.
Right. This is the force. Now we need to multiply with the distance. Distance is how much from here to here? 2 into
1.5.
from here to here.
2 into 0.5.
From here to here.
2.5.
2.5.
2.5, sir.
Next, minus. We need to consider this force. This is UDL. First thing, whenever there is a UDL, you need to write the UDL load. UDL लिखने के बाद क्या करना? उसको मल्टीप्लाई करना किसके साथ? लेंथ कितना है? टोटल लेंथ कितना है उसका? UDL का लेंथ कितना है?
मीटर.
2 मीटर है ना? 2 मीटर.
2 मीटर.
इसको मल्टीप्लाई करे तो क्या होता तुमको? ये UDL कन्वर्ट होके पॉइंट लोड हो जाता है. This UDL is converted into point load. Now the question is where this UDL is acting. This UDL acting at the center. At the center बोले तो
Center.
at the 1 meter. ये 2 मीटर है
One.
ना उसका, वो तो at a distance of 1 meter. From the free end कितना है इसका distance? यहाँ एक 1 मीटर है, इधर एक 0.5 मीटर. कितना हुआ total?
1
Into
1.5 1.5
Now simplify and tell me the answer.
35.
Minus 25.
Minus
Yeah?
35. 35, sir.
This get cancelled. पहले ये बोलो कितना होगा? ये -5 हुआ, माइनस 20, फिर ये कितना, ये इसको सिंप्लीफाई करो कितना तो
20 into 1.5 equal to 30, sir.
we are
Minus
calculating
55.
see we are calculating at this distance, right?
150
We are calculating where here, right?
and
See
at
here.
minus 30.
We are calculating the bending moment at point C, right? At point C, in the sense from here to here, what is the distance? What is the
2.5.
distance over
2.5.
here? Huh? We
2.5,
are
sir.
calculating bending moment at a point. Which point we are calculating?
2.5
Yes, you need to multiply with 2.5.
C.
See, थोड़ा तुम कंफ्यूज कर लिए, मैं बताता हूँ. देखो, थोड़ा सिंपल है ये. तुमको क्या डाउट आ रहा है बोलो तो इसमें एक ही डाउट आ रहा है ना. ये होगा इधर एक है और इधर एक लोड है. So we have one more load over here. Okay. Here intensity is 2 kilonewton over here. This is 3 kilonewton, right? How much this one? This is nothing but over 10 kilonewton per meter. And the length is given. What is the length? This is 1 meter. From here to here it is 1.5 meter. The entire UDL is 2 meter. This is 2 meter. From here to here it is 0.5 meter. Now this is section A. This is B. This is C. This is D. This is E. So we need to calculate bending moment at the point C, right? ये पॉइंट को कैलकुलेट करना है ना हमको, बेंडिंग मोमेंट है ना.
C, sir.
At point C, that's what I am writing here. At point C. Now, to calculate a bending moment at the point C, what we need to do? First, we need to consider the vertical forces. Vertical force क्या है? -2 kilonewton into, this is the force into distance. From here to here, what is the distance? It is
2.5.
2.5. ये clear होगा? Minus we have this 10 kilonewton into 10 kilonewton meter is the force. ये UDL है, UDL को पॉइंट लोड कन्वर्ट करने के लिए इसको क्या करना, मल्टीप्लाई विद 2. इफ यू मल्टीप्लाई विद 2 you will get, this is nothing but your point load. Where this point load is acting? Where this
Center.
is acting? At the center it is acting. Now tell me, what is the distance over here? Force into distance. The distance is
1.5.
1. If this is 1 meter over here, this is 0.5, 1.5. Tell me the answer.
Minus 35, sir.
-35. Okay. Kilonewton meter. Similarly, here at point B, bending moment at a point B, at this point, -2 kilonewton into the distance is 1.5, 0.5 means 2 to 4, right? Into 4. Again minus. From here, what we need to do first, this has to be converted 10 किलो न्यूटन है ना, इसको क्या करना, 10 किलो न्यूटन per meter into the distance is 2 meter. Once we convert this, next we need to write this is nothing but force. Next the distance. The distance is how much? WL square by 2 is the formula. WL square by 2. Okay. Tell me the answer now. What will be the distance over here? From here, how much distance? Yeah, as we know that it is acting at a distance of 1 meter here. So 1 meter plus 1.5. How much? 1 meter plus
2.5.
1.5. समझ में आ रहा है ना ये? यहाँ से आपको कितना है डिस्टेंस? इट इज एक्टिंग एट द मिडल. यूडीएल कन्वर्ट किए पॉइंट लोड को होने के बाद यहाँ से आपको कितना है डिस्टेंस इसका? इट इज एट अ डिस्टेंस ऑफ, दिस इज 1 मीटर, दिस इज 1.5 मीटर, मीन्स इट इज 2.5 मीटर ओवर हियर. So if you simplify this, you will get the answer.
Minus 58 kilonewton.
Yes, minus 58 kilonewton meter. This will be your bending moment. Next, similarly, bending moment at A. Calculate bending moment at the point A. Again, the same thing. What we need to do? Minus 2 kilonewton into the distance is how much from here to here? It is 5 meter. Next, minus we have this load. That is nothing but 10 kilonewton per meter into the load. If you multiply this, it will be converted into point load. Next, what we need to write? We need to write the distance. Distance is, it is acting at the middle, so 1.1 meter, 1.5 meter, 1 meter. So 2 meter, 3.5 meter.
3.5.
3.5 meter. Next, minus, we have this load, 3 kilonewton into the distance is 1 meter. Now tell me the answer.
Minus 80.
Minus 83, yeah?
minus 80 ರೀ ಸರ್.
80 ಆಗುತ್ತಾ? ಇದು ಎಷ್ಟು
83
ಆಯ್ತು?
ಸರ್.
5 10 ಇದು ಎಷ್ಟು ಆಯ್ತು?
83 ಸರ್. minus
5 10 ಇದೊಂದು 3 83 ಆಗುತ್ತಲ್ಲ?
ಇದು 83 ಸರ್.
Because we have this load, right? 3 kilonewton into this distance. Minus 83 kilonewton. It's very easy concept. Now what we need to do? We need to draw the shear force and bending moment diagram for this. Draw the bending moment diagram and send those bending moment diagram for these two problems in your group. अब दो problem solve किए ना? See, we have solved two problems, right? For these two problems, you need to draw in a notes very clearly the shear force and bending moment diagram, and you need to make it as a PDF and you need to send in the group. तुम्हारा ग्रुप में ये दोनों भी असाइनमेंट बोल के डालो एक बार. क्लियर? Okay. In the coming classes, we'll see when. In the coming classes, we'll see a cantilever beam subjected to UVL, uniformly distributed load. Uniformly distributed load in the sense the load is varying continuously. The load is varying continuously. The problems on this type of cantilever beam subjected to UVL we will see in the coming classes. I hope so it is clear. If you have any doubt regarding this, you can ask now. क्या भी डाउट रिया तो इसके ऊपर पूछ सकते हैं आप. Any doubt? We have remaining one concept. If you complete that concept, we almost completed 50% of the portion of this subject. This module. और एक concept है ये हो गया तो 50% हो जाता है. Next we have one more beam, simply supported beam. Again, simply supported beam subjected to point load. Simply supported beam subjected to UDL. Simply supported beam subjected to UVL. If you complete those 3 things, we are supposed to complete all the concept of the beams. Like your third model is supposed to complete in the very soon. I hope it is very easy. Okay, sir. Fine. We'll end the class now. Shall we end the class now?
Yes, sir.
Okay. If you have any doubt regarding this, you can ask after this class also. And you make sure that now you need to send the scanned copy of your 2 solved problem in your group. Clear? सभी लोग वो स्कैन्ड कॉपी है ना, वो उसको सेंड करो उसमें तुम्हारे ग्रुप में. करेंगे ना सभी? Ainan, Umar, Farooq, Anil. Immediately after completion of this class, you need to send the PDF. Okay, fine. We'll end the class. All the best. Do well. Study well. Don't waste your time.
Thank you, sir.
Okay.